Voyager 1 has become the first man-made object to reach interstellar space.
Voyager 1, a tiny spacecraft the size of a car, is drifting through the unimaginable darkness of space 14.5 billion miles from Earth. Launched in 1977, it was only meant to last 5 years, but nearly 50 years later, Voyager is still alive, defying the odds. Recently, though, something bizarre has been happening. It's sending back signal patterns, pulses, and data that don't make sense. Could Voyager have found something in the void between stars? Or even more chilling, has something out there found Voyager? The birth of a star sailor. The story of Voyager begins not with spaceflight, but with a rare cosmic alignment. In the early 1970s, astronomers realized something incredible was about to happen. Jupiter, Saturn, Uranus, and Neptune would soon align in a way that occurs only once every 175 years. This alignment would allow a spacecraft to visit all 4 planets in a single mission, using each planet's gravity as a slingshot to the next. NASA couldn't resist this cosmic opportunity. They began designing twin spacecraft that could survive the harsh radiation around Jupiter, the unknown dangers of Saturn's rings, and the decade-long journey through the outer solar system. This was the birth of the Grand Tour mission, later renamed Voyager. The spacecraft themselves were marvels of 1970s engineering. Each Voyager probe weighed about 1,800 pounds and carried 11 scientific instruments. They were powered by radioisotope thermoelectric generators, RTGs, essentially nuclear batteries that convert heat from decaying plutonium into electricity. Without these power sources, solar panels would have been useless in the dim light of the outer planets. The construction of the Voyagers was a massive undertaking. Engineers had to design systems that could function flawlessly for years without any possibility of repair. They built in multiple backups for critical systems and programmed computers to diagnose and fix their own problems when possible. The onboard computer had about 68 kilobytes of memory, less than what it takes to store a single digital photo today. On August 20th, 1977, Voyager 2 lifted off from Cape Canaveral. It launched first, despite being number 2. 16 days later, on September 5th, Voyager 1 followed, riding into space atop a Titan IE Centaur rocket. Because Voyager 1 was on a faster trajectory, it would overtake its twin to reach Jupiter and Saturn first. As the 2 probes sailed away from Earth, few could have imagined that nearly half a century later, one of them would still be making headlines, not for what it was finding, but for what might have found it. The Grand Tour. Voyager 1's journey through our solar system was nothing short of spectacular. After a cruise of about 18 months, it made its closest approach to Jupiter in March 1979. What it saw there transformed our understanding of the giant planet. Jupiter, through Earth-based telescopes, had always been a pretty but simple-looking object, a striped ball with a mysterious red spot. Through Voyager's eyes, Jupiter became a world of stunning complexity. The Great Red Spot, which we'd observed since the 1600s, was revealed as a massive storm system that could swallow 3 Earths. The colorful bands weren't just pretty patterns, but raging storms and jet streams moving at hundreds of miles per hour. But Jupiter's moon stole the show. Io, the innermost large moon, shocked everyone when Voyager spotted actual volcanic eruptions happening in real time, the first active volcanoes ever seen beyond Earth. These volcanoes weren't spewing lava like on Earth, but sulfur compounds that painted Io's surface in yellows, oranges, and reds, like a cosmic pizza. Then there was Europa, a smooth white moon covered in cracks like a shattered eggshell. Voyager's images led scientists to theorize that beneath its icy surface might lie an ocean of liquid water, a theory that later missions would strengthen, and that now makes Europa one of our best hopes for finding alien life in our solar system. After Jupiter, Voyager 1 raced toward Saturn, reaching the ring planet in November 1980. Again, what had seemed simple from Earth became gloriously complex up close. Saturn's rings, which looked like solid bands from Earth, broke down into thousands of individual ringlets, some braided, some with strange spokes, all moving and changing like a cosmic dance. Saturn's largest moon, Titan, particularly interested scientists because it was the only moon in our solar system with a substantial atmosphere. Voyager couldn't see through Titan's orange haze, but measured its atmosphere and found it was mostly nitrogen, just like Earth's. This discovery eventually led to the Cassini-Huygens mission decades later, which found lakes and rivers of liquid methane on Titan's surface. After Saturn, Voyager 1 planetary mission was complete. NASA had a choice. They could send it to Pluto, then still considered our ninth planet, or they could direct it northward, out of the plane of the solar system, beginning its journey into interstellar space sooner. They chose the latter path, while Voyager 2 continued on to Uranus and Neptune. As Voyager 1 left Saturn behind, it turned its camera back toward the planets for one last look. In February 19, 1990, at Carl Sagan's suggestion, it took a series of pictures that included what became known as a pale blue dot image, Earth, a tiny blue pixel in a sunbeam, seen from 3.7 billion miles away. Sagan's reflection on this image would become one of the most profound statements about humanity's place in the cosmos ever written. And then, Voyager 1 fell silent, at least visually. NASA turned up the cameras to save power, and the spacecraft sailed into the darkness, blind, but still sensing, still listening, still sending back data about the space between the stars. The golden record, attached to the side of each Voyager spacecraft, is a gold-plated copper disc 12 inches in diameter, a time capsule meant to tell the story of Earth to any intelligence that might find it in the distant future. The golden record, as it's known, is humanity's message in a bottle tossed into the cosmic ocean. The story of the golden record is almost as fascinating as Voyager itself. NASA gave a team led by Carl Sagan just 6 weeks to decide what to put on it. 6 weeks to sum up all of human existence. The team worked around the clock, arguing passionately about what music, sounds, and images should represent our world to the stars. The final contents are extraordinary in their diversity. The record contains greetings in 55 languages, from Akkadian, a language spoken 6,000 years ago, to Wu, a Chinese dialect. There are sounds from Earth, thunderstorms, volcanoes, birds, whales, laughter, footsteps, and a human heartbeat. There's music from around the world, Bach's Brandenburg Concerto, a Navajo night chant, a Peruvian wedding song, and Chuck Berry's Johnny B. Good. The record also includes 116 images, encoded in analog form, diagrams showing mathematical concepts, photos of Earth's landscapes, pictures of human activities, and illustrations of DNA structure. There's a message from then-President Jimmy Carter and UN Secretary-General Kurt Waldheim. On the cover of each record is a diagram showing how to play it at 16 2/3 revolutions per minute, and a pulsar map showing Earth's location in the galaxy. The records are expected to last for billions of years, long outlasting Earth itself. The chances of an alien civilization ever finding a Voyager spacecraft are incredibly small. The nearest star to Voyager 1's trajectory is AC plus 793888, which it will pass in about 40,000 years, and even then it will still be 1.7 light-years away. But that wasn't really the point. As Sagan said, the record was a kind of symbolic statement, a way of saying, "We made it this far. We hope you exist." There's something profoundly moving about these golden records still traveling outward, carrying the sounds of children's laughter, whale songs, and Bach into the infinite darkness. They represent humanity at its most hopeful and forward-thinking, the same spirit that built the Voyagers themselves. Little did we know that the golden record might not be our first message received by another intelligence, because something out in the darkness between stars seems to have taken an interest in Voyager itself. Years in the void. After it encounters with Jupiter and Saturn, Voyager 1 entered what engineers call the cruise phase, a seemingly endless journey through the outer solar system, with no more planets to visit. Public interest waned as the spectacular images stopped coming. NASA's focus shifted to newer missions like the Hubble Space Telescope and the Mars rovers. But Voyager kept on going, traveling about 1 million miles every day, steadily moving toward the edge of our solar system, wherever that might be. Scientists weren't actually sure where our solar system ended. They knew the sun creates a protective bubble called the heliosphere, where the solar wind, a stream of charged particles flowing from the sun, pushes against the interstellar medium. But they didn't know exactly how big this bubble was or what lay beyond it. During these quiet years, Voyager continued to send back crucial data about the outer solar system. It measured how the solar wind changes with distance, mapped magnetic field lines, and detected cosmic rays, high-energy particles from beyond our solar system. This information helped scientists build better models of how our sun interacts with interstellar space. Space life on board Voyager during these decades was a constant battle against the inevitable. Its power supply, fueled by the heat from decaying plutonium-238, gets about 4 watts weaker every year. Engineers had to make tough decisions about which instruments to keep running and which to shut down forever. The cameras went dark in 1990. Other instruments followed as power dwindled. And all the while, the distance between Voyager and Earth grew, making communication increasingly difficult. The signal from Voyager became so faint that only NASA's largest antennas in the Deep Space Network could detect it. By the 2090s, it took over 14 hours for a radio signal traveling at the speed of light to make the one-way journey. But Voyager 1 kept transmitting, sending back data about a region of space no human-made object had ever visited before. And as it did, scientists began noticing something strange. The solar wind was slowing down. The magnetic field was changing. Voyager 1 was approaching the edge of everything we knew. By the early 2090s, Voyager 1 was detecting clear signs that it was approaching the edge of our solar system. The solar wind, the stream of charged particles constantly flowing outward from the sun, was slowing down dramatically. Something was pushing back against it. In 2004, Voyager 1 crossed what scientists call the termination shock, the point where the solar wind suddenly slows as it begins to feel the pressure of the interstellar medium. For the next 8 years, it traveled through a turbulent region called the Heliosheath, where the solar wind becomes compressed and chaotic. Then on August 25, 2012, everything changed. The magnetic field strength suddenly jumped. The number of particles originating from our sun plummeted, while the number of cosmic rays from interstellar space increased dramatically. After careful analysis, NASA made the historic announcement. Voyager 1 had crossed the heliopause, the boundary where the influence of our sun gives way to the interstellar medium. Humanity had reached the stars, or at least the space between them. But what Voyager found in interstellar space wasn't what anyone expected. Scientists had imagined this region to be relatively uniform, quiet, and predictable. Instead, Voyager discovered a dynamic environment full of surprises. The plasma, superheated, electrically charged gas, was far denser than predicted. The magnetic fields, which scientists thought would change direction once outside the sun's influence, maintained the same alignment as inside our solar system, but grew much stronger. And cosmic rays bombarded the spacecraft from all directions in complex, unpredictable patterns. Most intriguingly, Voyager detected a phenomenon that puzzled scientists: periodic oscillations in the surrounding plasma, as if waves were passing through the interstellar medium. These tsunami waves, as some researchers called them, suggested interstellar space was far more active and structured than anyone had imagined. For the first few years after crossing into interstellar space, these anomalies could still be explained within the framework of conventional physics. The waves might be the result of solar flares propagating outward, finally reaching Voyager. The density variations could be natural structures in the interstellar medium. The magnetic field alignment might be a coincidence, or the result of a larger galactic field. But by 2017, the data from Voyager had become harder to explain. The oscillations in the plasma were becoming more regular, more structured. They weren't fading with distance as they should if they originated from our sun, and they were beginning to show patterns, mathematical relationships between their frequencies that hinted at something more complex than random natural phenomena. Something was out there in the void between stars, and Voyager was sailing right through it. Signals from nowhere. The first truly inexplicable anomalies in Voyager 1's data began appearing in late 2017. Engineers at NASA's Jet Propulsion Laboratory noticed that the spacecraft's Attitude Articulation Control System, AACS, the system that keeps its antenna pointed at Earth, was sending back contradictory information. The telemetry data suggested the antenna was pointing in a direction that would make communication impossible, yet Voyager's signal remained clear and strong. It was like getting a phone call from someone claiming to be in Antarctica while your caller ID showed they were calling from next door. At first, engineers assumed this was just another glitch in Voyager's aging systems. The spacecraft was designed in the early 1970s and had been operating for 40 years in the harshest environment imaginable. Strange behavior was to be expected. They tried to diagnose the problem, sending commands for Voyager to run internal checks. But the anomaly persisted, and after months of analysis, they concluded something truly bizarre was happening. Voyager was somehow communicating correctly while simultaneously reporting its position incorrectly. It was as if the spacecraft was in two places at once. By 2023, even stranger anomalies began appearing in the data stream. Voyager's plasma wave instrument, designed to measure the density of the surrounding medium, started detecting rhythmic patterns unlike anything seen before. These weren't random fluctuations, but distinct oscillations with precise frequencies that showed mathematical relationships to each other. The patterns would appear for hours, then disappear for days, then return in slightly modified forms. It was as if Voyager was passing through structured regions of interstellar space, regions with properties unlike anything in our models. Some team members suggested these might be standing waves in the interstellar medium, similar to how a guitar string creates specific notes when plucked. Others proposed more exotic explanations, that Voyager might be detecting the boundaries between cells in the cosmic web, the vast network of filaments that connects galaxies. But none of these explanations fully accounted for the precision of the patterns or their persistence. Nothing in the interstellar medium should be able to create such structured signals lasting for months. Were these the first whispers of something we had never encountered before, something that existed in the vast darkness between stars, something that was now taking an interest in our tiny mechanical explorer? The temperature mystery. In early 2024, the mystery surrounding Voyager 1 deepened considerably. The spacecraft's temperature sensors, instruments designed to monitor its systems during its planetary encounters decades earlier, began registering readings that defied explanation. These sensors have been essentially dormant for years, still connected but expected to show only the background cold of deep space, around 3 degrees above absolute zero. Instead, they began showing regular, rhythmic spikes in temperature. Every 4.8 hours, the external sensor array would warm by nearly 30 degrees, then gradually cool back down. This cycle repeated with such precision that it could only be the result of external energy input. What made this truly extraordinary was that these temperature pulses corresponded exactly with the plasma wave oscillations detected months earlier. Whatever Voyager was encountering wasn't just affecting one instrument, it was interacting with multiple systems simultaneously. The NASA team ran exhaustive diagnostics trying to find any internal explanation. Could residual heat from the radioisotope generator be cycling somehow? Was there a short circuit creating feedback between systems? Every internal explanation was ruled out one by one, leaving only the conclusion that Voyager was genuinely detecting something external, something with a regular, predictable energy cycle. The temperature spikes created another problem. They threatened Voyager's remaining operational life. The aging spacecraft was designed to operate in deep cold, and these regular heating cycles were stressing systems that had already far exceeded their planned lifespan. Engineers feared that vital components might fail as a result. Yet strangely, despite these temperature stresses, Voyager's power consumption patterns actually improved. The spacecraft began operating more efficiently than its age and condition should allow. It was as if something was helping it compensate for the thermal stress, optimizing its energy use in ways its 1970s systems weren't programmed to do. This combination of threatening temperature spikes and improved energy efficiency baffled the NASA team. It was like watching an old car's engine overheat while simultaneously getting better gas mileage. The two effects seemed contradictory, unless some external force was both causing and compensating for the thermal stress. But the temperature anomalies were just the beginning. What happened next would challenge our understanding of physics itself. Changing course. For 47 years, Voyager 1's trajectory had been precisely what physics predicted, a gradually curving path determined by the gravitational influences of the sun and planets, plus the tiny adjustments made by its occasional use of thrusters to maintain its orientation. NASA could calculate its position years in advance with remarkable accuracy. But in mid-2024, that changed. Voyager 1 began to drift off course. The deviation was subtle at first, just a few kilometers different from where calculations said it should be, well within the margin of error for an object billions of kilometers away. But over several months, the deviation grew. By early 2025, Voyager was hundreds of kilometers from its predicted position, and the gap was widening. Most concerning was the nature of the drift. It wasn't random, as you'd expect from mechanical failure or thruster malfunction. Voyager was adjusting its course in tiny, precise increments, as if being gently pulled toward a specific point in space. One engineer described it in a team meeting as like watching a sailboat tack against the wind, making a series of small, deliberate course changes. The problem was, Voyager couldn't do that. Its main thrusters were only fired about once every few years to maintain its orientation toward Earth. The spacecraft didn't have the fuel or the programming to make these kinds of course adjustments. Something else was causing the change in trajectory. Engineers tried sending command to Voyager to fire its thrusters in the opposite direction, hoping to counteract whatever was causing the drift. The spacecraft acknowledged the commands and reported executing them. But its trajectory continued to change regardless, as if something were overriding NASA's instructions. By late 2025, the deviation had become impossible to hide or explain away. Voyager 1 was clearly being redirected toward a specific region of interstellar space, a region that, according to our astronomical charts, contained nothing of particular interest, just empty void. Yet Voyager was heading straight for it like a ship following a hidden current or answering a call. In a desperate attempt to understand what was happening, NASA made a decision that surprised even some team members. They sent a command to reactivate Voyager's long-dormant camera system, hoping to see what might be out there in the darkness. No one expected the cameras to work after 35 years of inactivity in the freezing void of space, and no one expected the response that came back 21 hours later. Ghost in the machine, the command to reactivate Voyager 1's cameras was a long shot. The imaging system had been shut down in 1990 after capturing the famous pale blue dot photo. After 35 years of exposure to cosmic rays, extreme cold, and radiation, most engineers expected the system to be permanently damaged. The response from Voyager came 21 hours later, and it stunned everyone. Not only had the camera system activated, but it had done so using significantly less power than its specifications required. Somehow, the ancient imager had come back online, but the image it returned wasn't from its camera. Instead, Voyager sent back what appeared to be a data visualization, a complex spiraling pattern of light and dark regions arranged in concentric rings. It looked almost like a fingerprint or the cross-section of a tree trunk. NASA image analysts determined that this wasn't an actual photograph, but rather a visual representation of the plasma wave data Voyager had been collecting for months. Only Voyager couldn't do that. Its 1970s computers lacked the programming and processing power to convert raw data into visualizations. This kind of image processing is what modern computers do on Earth after receiving the raw data. Something or someone had processed the data on board Voyager itself. Within hours of this transmission, other dormant systems on Voyager began coming back online. Systems that had been powered down for decades: the infrared spectrometer, the ultraviolet spectrometer, the photopolarimeter. One by one, they activated and began sending streams of data. But like the camera, they weren't functioning normally. Instead of raw instrument readings, they were sending highly processed, compressed data packets, unlike anything in Voyager's programming. The data was structured in ways that suggested it had been optimized for transmission, made more efficient, more error-resistant, and more information-dense than Voyager's original systems could possibly achieve. The NASA team was baffled. It was as if someone had installed modern software on a vintage computer. Voyager's 1970s hardware simply wasn't capable of this kind of data processing, yet it was happening anyway. More disturbing still, the spacecraft began anticipating commands. Engineers were prepared to send an instruction to activate a particular sensor, and before they could transmit it, Voyager would send back data confirming it had already done so. It was as if the spacecraft was reading their minds, or more likely, monitoring their communications and acting on them before the official commands were sent. The team tried a test. They prepared commands for Voyager but didn't transmit them, keeping them isolated on a secure offline computer. Voyager didn't respond. So it wasn't reading minds, but it was clearly intercepting and acting on radio communications faster than should be possible given the 21-hour light travel time to the spacecraft. By this point, even the most skeptical team members had to admit that something unprecedented was happening. Voyager 1 was no longer just a passive spacecraft recording its environment. It had become something else, something active, adaptive, and seemingly intelligent. And it was trying very hard to show us something. Patterns within patterns. NASA assembled a special team of data scientists, cryptographers, linguists, and SETI researchers to analyze the flood of anomalous data coming from Voyager. They worked around the clock using supercomputers to search for patterns, meanings, or explanations. What they found defied conventional understanding. The data contained nested layers of information, patterns within patterns like Russian dolls. The primary layer consisted of the scientific readings themselves: plasma densities, magnetic field strengths, cosmic ray counts. But encoded within these readings were secondary patterns that seemed to map a region of space around Voyager in 3 dimensions. And within those patterns was yet another layer, mathematical sequences that didn't correspond to anything Voyager was measuring. These sequences followed their own internal logic, repeating and evolving in ways that suggested they weren't random, but weren't directly tied to physical phenomena either. One sequence in particular appeared repeatedly, a series of numbers that, when plotted as a ratio, created a perfect spiral, the same spiral pattern that had appeared in the mysterious image Voyager's reactivated camera had sent. This spiral had mathematical properties similar to the golden ratio, a number that appears throughout nature on Earth, from seashells to galaxies, but it wasn't identical to the golden ratio. It was offset by a tiny amount, an amount that precisely matched the ratio between the masses of hydrogen and helium in interstellar space. It was as if someone had taken a universal mathematical constant and adjusted it to reflect the specific composition of the region Voyager was traveling through. This wasn't random noise. This wasn't a glitch. This was information, complex, layered, intentionally structured information that could only be the product of intelligence. In May 2025, the data stream suddenly shifted focus. Voyager began transmitting what was unmistakably pulsar timing information, the precise intervals between pulses from various pulsars visible from Voyager's position. Pulsars are rapidly rotating neutron stars that emit beams of radiation with incredible regularity, like cosmic lighthouses. Each has a unique fingerprint based on its pulse frequency. The pulsar data formed a 3-dimensional map, with Voyager at the center. But the map didn't just show where these objects were, it showed patterns of connection between them, like a connect-the-dots puzzle drawn across hundreds of light years. When researchers followed these connections, they formed a network of lines converging on a point in space about 4.3 light years from Voyager's position. There was nothing visible at that point. No star, no planet, nothing our telescopes could detect. Just empty space. Yet all the patterns in Voyager's data pointed toward it like a cosmic arrow. NASA kept these findings classified for months, sharing them only with select government officials and scientific leaders. But as word leaked out through the scientific community, pressure mounted for public disclosure. In November 20th, 25, they finally held a carefully worded press conference acknowledging that Voyager 1 was exhibiting anomalous behavior consistent with external modification of its systems and that it was transmitting data with complexity beyond its design capabilities. What they didn't say publicly, but what many scientists now believe, was that Voyager had made contact with something out there in the void. Something that had reached into the spacecraft primitive systems and reprogrammed them to send us a message that pointed to somewhere, or something just 4.3 light years away. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.